Bismillahirrahmanirrahim. Dear students, today we start chapter number 19 for the grade 12, aldehydes and ketones. This is lecture number 54, aldehydes and ketones for grade 12, chapter number 19, nomenclature of aldehydes and ketones. In the aldehydes, carbon atom of carbonyl group is directly attached with at least one hydrogen atom. Aldehydes. This is a carbonyl group. This is a carbonyl group, and one side must be attached with the one hydrogen atom. This is the aldehyde. And for the ketones, carbonyl group, same carbonyl group, attached on both sides alkyl group. Both sides alkyl group. This may be hydrogen, may be alkyl group, but there must be two alkyl groups. So general formula is CnH2nO for both. CnH2nO. This is the general formula for the both aldehydes and ketones. Aldehydes go unpresent in the most of sugars. They are principal constituents of a number of essential oils used in the fragrance and flavors. Ketone present in most in the camphor and fructose. Examples are for aldehydes. You can write also. Like this one. This is a formaldehyde. Formaldehyde. In that IUPAC name, this carbon is one with aldehyde nal. Methanol. This is called methanol. Formaldehyde or methanol. This is acetaldehyde. Or ethanol. And this ketone. This is the acetone. Nail polish remover acetone. And dimethyl ketone, or propanone. This is the butanone. So these are the few examples of aldehydes and ketones. Formaldehyde, acetaldehyde, and if you are going to give the other names also, common names, an aldehyde name after the name of carboxylic acid obtained by the oxidation, ending is placed aldehyde. The aldehyde using alpha, beta, and gamma names like this one. CH3, CH, like this one. This is a functional group. This functional group, next carbon is called alpha carbon, and then it is called beta carbon. So this is the alpha carbon, alpha methyl alpha alpha methyl propanaldehyde. Propanaldehyde or 1 2 3 2 methyl propanol. So these are the nomenclatures of aldehydes. Like this. This is a 2-chloro, 2-chloro ethanol, or this is the alpha. So alpha chloro ethanol or ethylaldehyde. Other also CH3, CH3, CH, Br, if like this, this is a aldehyde and there is a carbon, you must include this. 1 2 3 4 5. Alphabetically 3 bromo, 4 methyl, 3 bromo, 4 methyl pentanol. This is a nomenclature of aldehydes. For the ketones, same. For the ketone, CH3, CH2, ketone functional group, CH2OH. Must start from where? 1 2 3 4. So there will be a 1 ol and 2 butanone. 1 ol, 2 butanone. This is the functional group. This is the alpha carbon and this is the alpha dash carbon. So this is the alpha hydroxy, alpha hydroxy and methyl ethyl ketone. Methyl ethyl ketone. Methyl ethyl ketone. There are others also. By this one. So 1 2 3. 1 2 3 and 1 2 3 4. This must start from this side. 1 2 3 4 5 6. So 2 methyl 3 hex hexanone. 3-methyl hexanone. And there are also other names for giving the aldehydes and ketones. So I'm writing others, just like this is cyclohexane, this is cyclohexanone. There the carbon double bond, this is cyclohexanone. If you put methyl here or methyl here, so starting number from this side 1, 2, 6, 2,6-dimethyl cyclohexanone. 2,6. 1, 2, 3, 4, 5, 6. Starting from this carbon which is connected here. So this is the 2, this methyl, 6, this methyl, 2, 6 dimethyl and hexanone. One position is for the ketone. This is a propanone, cyclopropanone, 2,6-dimethyl cyclohexanone. This is a cyclopropanone. Here are the quick quiz I am going to solve like this one. CH3, H3, double bond CH, C double bond O, CH, like this one. So 1, 2, double bond under 2, 3, 4, there is a ketone, 1, 2, there the branch, functional group on the position number 2. So 1, 2, 3, 4, 5, 6. So 1, 2, methyl, 3, ketone, 4, 5, again methyl, and there is a double bond. So write 4 in, and 2, 5 dimethyl. This is a double bond between carbon 4 and 5, so this is a double bond. So that's why we write 4 in, and the carbon number 2 methyl group, and the carbon number 5 methyl group, so 2, 5 dimethyl, and the functional group is at carbon number 3. Total carbons are 6, 3 hexanone. So this is the nomenclature. Nomenclature you have to practice for it. After nomenclature, there are the physical properties of the aldehydes and ketones. Aldehyde has a carbonyl functional group. Ketone also has a carbonyl, which is a polar in nature. So due to the difference of electronegativity means dipole-dipole interactions are there in the aldehydes and ketones. Though the carbonyl group is not from a hydrogen bonding because the carbon and hydrogen are not directly attached with oxygen, that's why only it has dipole-dipole interactions. Not like a water. The implications of these effects are high melting points, boiling points compared to analogous of alkanes. Alkanes are completely, they are non-polar in nature because of the carbon and hydrogen are there, but here carbon, oxygen and hydrogen maybe, but carbon, oxygens are there. Lower boiling point than analogous of alcohol because in the alcohols and water strong hydrogen bonding is there, but in the aldehydes and ketones the hydrogen bond is not. More soluble than alkanes. Alkanes are purely non-polar hydrocarbons but less soluble than alcohols in aqueous medium. Now after preparation of aldehydes and ketones, we are going to start preparation of aldehydes and ketones preparation. Preparations of aldehydes and ketone. First method is from the ozonolysis. Ozonolysis of alkenes. Ozonolysis of alkenes. So dear students, I am writing here. This is a carbon. This is a alkyl group. There is also alkyl group. This is a double bond. Carbon. And this is the alkyl group and there is an alkyl group. This is alkyl group number 1, 2, 3 and 4. This is the method number 1. Ozonolysis of alkenes. Ozonolysis of alkenes. So this is the very simple if I write in the general way. Break this double bond, put oxygen here and oxygen here. Break this double bond, put oxygen here and oxygen here, you will get ketone, like this one. Like this one. So if I break this bond, then double bond O, like this, you will get ketones. You will get ketone group, 2 molecules of the ketones. So now how we write the mechanism for this chemical reaction? So the mechanism is alkyl group 2, alkyl group 1, this alkyl group number 3 and alkyl group number 4, and there is a ozonolysis. So dear students, in this ozonolysis what we have to do, there are 3 oxygen atoms. Put these oxygen here. So I am going to write. This is a carbon and this is the alkyl group 1, there is alkyl group 2, oxygen, and this is the carbon number 2, alkyl group number 3, alkyl group number 4, like this one. So if you are going to write this, and if you connect this oxygen, connect this oxygen to here, and these two oxygen directly, this is called a ozonide. What you call this? Ozonide. Here is a ozonide. Then there is a cleavage, breaking of bonding taking place. How this breaking of bonding? This, like this one. There is a breaking of bond. So when you break this bond, and you have to put water. So this is the alkyl, this is the carbon. Alkyl group number 1, alkyl group number 2. And there is the carbon and with oxygen. So this same one molecule of ketone is going to be formed here. And there is the alkyl group number 3, alkyl group number 4, and double bond, this carbon, oxygen. So you will get another molecule of the ketone, this oxygen and water for the time being. They form hydrogen peroxide. Put the zinc dust, you will get zinc oxide and again water. So you will get the two molecules of aldehydes, and ketones, maybe symmetrical, maybe unsymmetrical, maybe ketone, maybe aldehyde, maybe two aldehydes, maybe two ketones. So this is the first method for the preparation of aldehydes and ketones. So if I am going to prepare aldehyde, okay, no problem. Same. No alkyl groups. See, formaldehyde. Just replace alkyl. So this is the ethene. You will get the symmetrical aldehydes. And if you are going to here hydrogen, then you will get like this. So in this case you will get one aldehyde and another ketone. It is your choice what's the nature of the alkene you are using. Just like ethene, I get the same aldehyde formaldehydes. If I put alkyl here and alkyl here, then I will get two acetaldehydes. If the hydrogen is there and all the alkyl groups, then I will get one aldehyde and one ketone. So it's your choice. So this is the ozonolysis. First one method. Now second is the hydration of alkynes. Aqueous solution of sulfuric acid and mercury sulfate as a catalyst used for the preparation of aldehydes or ketone, the vinyl alcohol that is initially product is as. So if you are using alkynes and sulfuric acid, mercury sulfate as a catalyst. So sulfuric acid should be dilute in nature, partial positive charge, partial negative charge. Sulfuric acid will not participate in the chemical reaction, it's water only. We make dilute sulfuric acid and mercury sulfate as a catalyst. So this water is going to be combined with the alkynes indirectly. So you will get the one hydrogen will be attached here to make a CH2, triple bond in double bond, then CHOH. This is called vinyl alcohol. This is called vinyl alcohol. This vinyl alcohol has a rearrangement of the vinyl alcohol. So this hydrogen is going to be attached here to CH2 change into CH3, and there is a CHO, so you will get aldehyde here. It's an R. So this is the ethanol. So only the acetylene give aldehydes. Other aldehydes they form ketone. Only the ethyl or acetylene give aldehydes. Other, this is a propyne. Same. Same conditions. So dear students, you learned the Markovnikov's rule in alkene or alkyne. Markovnikov rules that if this unsaturated hydrocarbons is unsymmetrical, there the one carbon no hydrogen and there the carbon with hydrogen. So this is not used because current system such like. So this is the unsymmetrical alkyne. And the reagent which is different positive and negative. So the negative part this must attach with the carbon which has no hydrogen. This is according to Markovnikov's rule. So OH will be attached here and CH2. So put double bond here. Triple bond changes into double bond to hydroxypropene. To hydroxypropene, and there is a rearrangement. Rearrangement taking place, and what happens? This pi bond, double bond, shifts here like this one, and this hydrogen will go there. So this is CH3, same bond. This double bond change into single bond. Hydrogen is going to be attached to make a CH3. Between carbon and oxygen, double bond is established. So you will get ketone, propanone. Formation of ketone. So all other aldehydes they give alkynes give the ketone because of unsymmetrical carbon is there according to Markovnikov's rule. So if you have another compound, like this one, benzene acetylene. So this is benzene acetylene same. So again this carbon is unsymmetrical carbon. This OH will be here. Put the big circle, not small. OH, like this one. This is the temporary rearrangement taking place. Same arrangement will go there. And this ketone is going to be formed. You will get this compound. This is called acetophenone. Or methyl phenyl ketone. Methyl phenyl ketone or acetophenone is going to be formed here. So this is a second method. The third method is oxidation of primary and secondary alcohols. You done in the previous case in the alcohols chapter. So primary alcohols, after the catalytic oxidation, you done in the chapter. This is review for you. This is a review. Same oxidation, catalytic oxidation of alcohols. This is an ethanol, and this is a nascent oxidant which is formed from concentrated sulfuric acid, potassium dichromate or potassium permanganate. They give this nascent oxygen. There is dehydration. OH is going to move from here and hydrogen is going to move from this. So you will get aldehyde and water. This is the aldehyde going to be formed, and this is called a ethanol. You can also form the propanol, and secondary alcohol gives ketone. Secondary alcohols give ketone. Concentrated sulfuric acid, mercury sulfate as a catalyst. So this hydrogen and OH remove. So propanone, this is a ketone, and this is aldehyde. So aldehydes and ketone are going to be formed in this case. Now this you done this alkyl halide Frieders and Crafts reactions. Frieders and Crafts reaction, you done this one. Here is a acylation. This is acylation of the benzene, you done this. I'm not going to write the category you done before. Put the methyl. So partial positive charge, partial negative charge. Prepare the strong electrophile. There is a pi electron of benzene, and the catalyst is aluminum chloride. You done before. Acylation of benzene and alkylation of benzene according to the Frieders-Crafts reaction. So this acyl group is going to be attached and formation of acid. Again, we will get acetophenol is going to be formed here. So you can get this. There is another method for the preparation of aldehydes and ketones. Calcium acetate. This is a calcium acetate. CH3COO, CH3C. This is a calcium acetate. We put dry distillation. This is salt in the solid state. We don't put the oxygen, we don't give oxygen. Dry distillation of the calcium acetate. So there is a decarboxylation. Calcium carbonate is going to be formed. Like this. Calcium carbonate and ketone. Like this. Calcium carbonate and ketone is going to be formed here. When there is a dry distillation of the calcium acetate, it's a calcium acetate. And students, if you are going to put together calcium acetate and calcium formate, this is a calcium formate. Both, if calcium acetate and calcium formate both by dry distillation, then you will get aldehyde. 2 calcium carbonate. This is a CH3, CO, and this H. In this case, aldehyde is going to be formed. CH3, COH, and COH and CH3, the 2 molecules of aldehyde, plus 2 moles of calcium carbonate. So when you are going to distillate calcium acetate and calcium formate together, then you will get the aldehyde molecules. But if you are going to dry distillation of only calcium acetate, then you will get the ketones. So dear students, these are the methods or preparations of the aldehydes and ketones. by using different reagents, organic compounds. So inshallah we will do the reactivity, very important things there. Reactions are very important for the aldehydes and ketones. So in the next lecture, inshallah, we will discuss these. Thank you.